1943, it was decided that an experimental charcoal iron plant should be established at Wundowie, a place that is now fast becoming famous for the production of high-grade charcoal iron. This unique and highly integrated industry is situated about 40 miles from Perth and is on the fringe of the Jarrah belt. Throughout the Jarrah country occur many outcrops of iron ore. These are usually low-grade deposits but are very useful for blending with higher grades. Western Australia is endowed with huge jarrah forests occurring as virtually single species. Wundowie operates an area of forest country of roughly 15 miles radius. In all, there are 4 million acres of jarrah forest in this state. It is a valuable timber, but the waste wood averages about 40 tons per acre. At present, there is no use for this waste other than the production of charcoal. The field operations are almost entirely mechanized. Mobile power saws are used for felling the trees and then for docking the logs to convenient lengths for milling. The logs are immediately buffed. After cutting an area, the boles, unsuitable for milling, and the limbwood are left to dry for periods of up to 2 years. Cutters again cover the area, sawing the wood into 3-foot lengths and splitting it ready for the retort. It is loaded onto heavy-duty trucks and carted to the plant. On the present scale of operations, it is estimated that well over 100 years' supply of wood is available. The land being cleared is mainly used for grazing purposes as soon as suitable pasture is established. Mobile jib cranes and tractors load the mill logs onto the diesel transport. Each year, an average of 45,000 tons of logs are conveyed to the works. At the works, each diesel transport with its load of logs is checked over the certified weighbridge. The logs are handled in 2 modern sawmills with a combined average annual output of 12,000 tons of sawn timber. The great twin circular saws commence their task of conversion. As much sawn timber as possible is recovered from the logs. Sufficient scantling for 2 homes is produced each day. Selected timber is conveyed by mobile timber forklifts from the mill to the drying stacks. Here, in a suitable climate and on an elevated position, the picked timber is carefully stacked. Separating strips of timber allow the boards and planks to season by the natural method. Waste timber from the mill, not suitable for even fruit case sizes, is drawn on a slow-moving elevator to the continuously revolving gang saws. "25,000 tons of this blockwood or mill ends are produced each year. Controlled by a wheel, the blockwood falls from the hopper to the latticed steel wagons called wood buggies. Each buggy contains about 2.5 cords or 9,000 pounds. These buggies are drawn as required from the mill or the cordwood stack. An electrically driven transporter moves the buggies in rakes of 4 to the retort. Each retort, holding 4 buggies, is heated externally by means of blast furnace gas and gas drawn from the wood distillation process. Each distillation cycle takes about 24 hours, depending on the initial moisture content of the wood. "12,000 gallons of pyroligneous acid containing water, tars, acetic acid, and methanol are processed daily from the destructive distillation of 96 tons of wood. In the refinery, this liquor is processed by the fractionating method. This panel of meters automatically controls the flow of liquids through the refinery. 24 hours a day, the plant must be kept in operation. Crude methanol and other low-boiling products like acetone, aldehydes, and methyl acetates are distilled in a bubble-capped column. The crude methanol is refined by further distillation, yielding pure methanol, methyl acetone, and wood naphtha. From the fractionating column is produced glacial or pure acetic acid, as well as a technical or industrial grade. Heavy stainless steel drums preserve the contents against contamination or loss during transport and marketing throughout Australia. A high demand comes from the industrial firms of Sydney. 90% acetic acid used mainly as a food preservative, such as sauces or pickles. Glacial acetic acid, 99% pure. Methyl alcohols used in textiles, paints, and varnishes. Although local ore with about 45% iron content was originally used, Uren now supplies the main requirements of hematite ore. Uren is 221 miles from Wundowie. All ore is mined by open cut method. This outcrop rises 300 feet above the surrounding country. It is estimated that at least 100 million tons of high-quality ore is above the water table. Uren ore has excellent physical properties, as well as a high iron content of 62.5%. At the quarry, mined ore is crushed, screened, and graded, and then conveyed to elevated storage bins. The crushed ore is transported by heavy-duty road trucks to Southern Cross, a distance of 30 miles. At the cross, it is tipped into steel end-tipping railway trucks for its long journey to Wundowie. At Wundowie, after samples are tested, the ore is placed in segregated heaps and bins. It is fed into the blast furnace in carefully calculated proportions. The production of charcoal is a continuous process. The waste wood, after 24 hours of baking, bursts into flame on meeting the air. Such flames quickly subside in the coolers. The final product, a high-quality charcoal, is withdrawn from the coolers and tipped from the buggies into the storage bin. The blast furnace is basically a steel shell lined internally with special bricks. Raw materials are fed into the top of the furnace by a skip car. Beneath the bins, predetermined quantities of iron ore, magnesite, limestone, manganese, and charcoal are measured into the skip. The burden is mixed on a double bell top before dropping onto the furnace. Steam raising plant is essential for electric power and the many steam returners. The boilers consume sawdust which is blown in by air. Tar from the wood distillation process, blast furnace gas not required by the retort, and limbwood from the bush clearing. A blast of air heated to 1000 degrees Fahrenheit burns the charcoal. Every 5 hours, night and day, the furnace must be tapped, releasing the molten metal brought down by the terrific internal heat. The iron flows freely from the furnace with a bright glow. The thick slag follows sluggishly. This byproduct is sold for insulation purposes. The iron passes under a gate and over a weir to the ladle. This is lined with fire bricks and holds 10 tons of metal. From the ladle, the iron is pigged on a casting machine. Filled molds pass under a water spray to cool the pigs before they drop into the waiting truck. The casting machine produces pigs each weighing about 45 pounds not, uniformly shaped and free from sand. Scrupulous care is taken in testing all production. During the molding, samples are made from the ladle and analyzed by the chemist. Every cast is numbered and kept separate to meet all desired specifications. As Wundowie special irons are well received and in good demand in the eastern states and overseas, correct and reliable grading is essential. A complete range of foundry iron is made for local needs. Special irons include those low in sulfur, phosphorus, manganese, titanium, and other trace elements. Most of the production is shipped from Fremantle 52 miles from Wundowie. Shipments are made direct by diesel road transport or from the stock depot adjoining the North Wharf. Here, to enable quick handling into ship holds, the electromagnet loads into steel trays on flat trucks. The electromagnet is an interesting item of equipment, saving considerable time and much back-breaking manhandling of the pig iron. Where might this pig iron be going? To Argentina, to Canada, to Switzerland, or San Francisco? It has been sold to the four corners of the world. From all customers, there are good reports and pressing requests for further supplies. This highly integrated industry is an interesting demonstration of complete utilization of a very small part of the vast forest and metallurgical assets of Western Australia.